This is Mr. Anderson from Kellogg Community College. We are going to look at our Part 3 of Chapter 2, Section 3, and we're going to look at some odd-even properties of negative angle rotations. And one thing about the odd-even properties is that cosine and secant, these two, cosine and secant, the negative angle rotations are the same thing as the positive angle rotations. So if you have a cosine of a negative angle rotation, that's going to be equal to the cosine of the angle. So for example, in this problem here, the cosine of negative 30 is the same thing as cosine of 30 degrees. But the same thing goes for secant, so there are no examples of that on this page, but the secant of a negative angle rotation is going to be the same thing as secant of the positive. But when we deal with any other of these that have workings with the y variable, the negative value of that is going to be negative of the entire thing. So if you're looking at the sine of negative 135, this is going to be equivalent to the negative of the sine of 135 degrees. This is important too because we don't have to do negative spins around the circle. We can just take the opposite value of what this is when we do a counterclockwise rotation instead of a clockwise rotation. So this is going to be the negative cosecant of 30 degrees, like that. I should probably have the degree inside the parenthesis there. This is going to be, since this is cosine, this is going to be a cosine of 270 degrees right there. Again, because the odd-even property means, or the even-odd property means that this is going to be positive. And then here, sine, this is going to be negative sine of pi, and then down here, this is going to be negative sine of pi over 3. Now, we're going to find these values here, but I just wanted to do these little quick conversions using our even-odd properties to these problems here. So getting down to the bottom here, to these three. So we're going to take a look at, this is our, we covered this sine already, which is going to be negative sine pi over 3. This is going to be negative sine, I think I got my pen on here. Yep, negative sine 3 pi over 2, and this is going to be, since this is secant, we're okay here, this is going to be secant of pi, and then down here the cosecant, this is, I'm sorry, that's so far down there, the cosecant is going to be negative cosecant pi over 3. Now what I want to do is I want to actually go to my unit circle and do these problems, numbers 24 through 32, on the unit circle so you can see them. So let's go take a look at problem number 24, which says it's the cosine of negative 30 degrees is the same thing as the cosine of 30 degrees. So 30 degrees, cosine, the x value, square root of 3 over 2. So this would be problem number 24. Problem number 25, the negative, let's see, the sine of negative 135 degrees is the sine of 135 degrees, but negative. So the sine is the y value, so here is the y value, and we're going to make it negative. So this is going to be problem number 25. The answer to problem 25 is negative square root of 2 over 2. The negative, the cosine of negative, the cosecant, sorry, for this is problem 26, the cosecant of negative 30 degrees is the same thing as negative cosecant of 30 degrees. So let's go to 30 degrees here. We're going to take our, the cosecant is the sine, so we're going to take our 1 over 2, flip it on its head, and we flip it on its head, and that would make 2 over 1, or just 2. But negative cosecant of 30 degrees would be negative 2. So it's kind of nice to find these equivalencies right here on the unit circle. So this is problem number 26. Problem number 27, the cosine of negative 270 degrees, which is way down here, is the same thing as cosine of 270 without any negative modifiers on there. And since that is going to be our x value, the answer for number 27 is 0. The answer for number 28, which is going to be sine of negative pi, which is rewritten as negative sine of pi, is going to be, let's see, our y value here is 0 because sine is 0, and therefore negative 0 is simplified to 0. So 0 is our answer for problem number 28. Problem number 29, we're going to have a negative sine pi over 3. Negative sine pi over 3. So we go to pi over 3, which is way up here. Sine is our y value, and we put a negative in front of it. So negative square root of 3 over 2. That's problem number 29. Problem number 30, we're going to have our negative sine of 3 pi over 2. So we go to 3 pi over 2, which is down here again. This is our negative sine 3 pi over 2 because we move the negative out in front. 3 pi over 2, our y value is negative 1, and therefore negative negative 1 is positive 1. So our positive 1 value there is going to be our answer for problem number 30. Moving on to problem 31, which is secant of negative pi. With our odd or even odd rules or even odd properties, the pi is positive there. So the secant of pi is the same thing as 1 over cosine. Cosine is our x value. So 1 over negative 1 is negative 1. So this right here is our answer for 31. After we go 1 over that answer, of course. Then finally, to end the problem for number 32, the cosecant of negative pi over 3 is the same thing as negative cosecant of pi over 3. And if you take a look, pi over 3 is up here, so I'm going to put negative cosecant pi over 3. And what we'll do there is we will take a look at the 1 over sine value, and sine is going to be our y value here. So we flip this on its head, and since we've done this many times before on the unit circle, this is going to be 2 square root of 3 over 3, and because we have a negative in front of cosecant, boom, there is our answer for problem number 32. Okay, so let's keep moving on to the last part here. The last part is to use some trigonometric functions and to find some exact values. We can't use any calculators here, so there's got to be some pretty cool tricks. The one trick you definitely need to remember from our session 1 video at the very end was what we learned about the unit circle. What we learned about the unit circle is that any circle is x squared plus y squared equals 1. Now, since sine and cosine are x and y, then we have our cosine of cosine squared theta plus sine squared theta is equal to 1. And most books have that written the other way around, sine squared theta plus cosine squared theta equals 1. But there's also some actual like other formulas we can derive from this. If we divide everything here by cosine squared theta, what we would get is 1, because cosine divided by cosine is 1, and we'd get tangent, because sine over cosine is tangent, would be 1 over cosine or secant squared theta. So there's an alternative that we will use in this function right there. But I do want to circle this here because we can do one more here, dividing both of these by sine. Cosine squared theta divided by sine squared theta is cotangent squared theta. Sine squared theta divided by sine squared theta is 1. And then 1 divided by sine squared theta is cosecant squared theta. So we got this equation, we got all three equations here. So it's got to be something we can do here actually, and take a look. We've got secant squared theta is equal to 1 plus tangent squared theta. So I'm going to take this and use the transitive property, because 1 plus tangent squared equals secant squared theta. Secant squared this I'm going to use substitution. So instead of me writing down the secant squared 18 degrees, I'm going to write in 1 plus tangent squared 18 degrees minus tangent squared 18 degrees. And the tangent squared 18 degrees minus tangent squared 18 degrees is 0. So the answer here is 1. Now it's nice to know our SOHCAHTOA here, and it's nice to know our properties here. The tangent is the same thing as sine over cosine, or you can kind of simplify this and write, well, shoot, cotangent of 10 degrees is the same thing as 1 over tangent of 10 degrees. And tangent times 1 over tangent of 10 degrees is going to be 1, because 1 over 1. Problem number 35 here, we got cotangent of 20 degrees, which is the same thing as our cosine of 20 degrees, because this is cosine over sine. That's the definition of tangent. Sine of 20 degrees minus cosine of 20 degrees minus the sine of 20 degrees. Anything minus itself is 0. You can see where these kind of simplified and, some neat answers here. Now this one threw me for a loop the first time, but I had to remember that tangent and cotangent are periodic for every pi radians. So for every 180 degrees, you basically can just say, okay, well, tangent of 200 degrees, 180 degrees beyond that would be tangent of 20 degrees, because they would be a periodic. Every 180, it kind of loops over itself. Tangent and cotangent are the only two functions that don't have to go 360 degrees to become kind of like loops on themselves. And then cotangent, of course, is 1 over tangent of 20 degrees. And they simplify. The answer is 1. All right, now secant and cosine right there. This is going to be some little odd even properties right here, because secant is secant's okay, which means that, if we take the secant of a negative rotation, that's going to be the same thing as our positive rotation right there, because secant and cosine are positive on their even odd properties. So this is just going to be written as secant of pi over 18. So again, negative is equivalent to this positive. Now the cosine, we are again going to work on this a little bit here. 18 times 2 is 36. So you can have 36 pi over 18 plus pi over 18. You see what is happening here? What this means is that this is 2 pi, and therefore this is a full revolution, so this can be written as cosine of pi over 18. Now secant is just another way of writing 1 over cosine. So if the secant is 1 over cosine of pi over 18 times cosine of pi over 18, we have 1, because that just simplifies there. All right, here's another odd even property. The cosine of this negative angle right there is the same thing as the positive angle. So this is going to be the same thing as 430. But if you take one revolution clockwise around the circle, this takes you down to the cosine of 70 degrees. So we have sine of 70 degrees over cosine of 70 degrees. The tangent of negative 70 can be written as, instead of plus, minus tangent of 70 degrees. Sine over cosine is tangent. So we got tangent of 70 degrees minus tangent of 70 degrees. What trickery is this? 0. All right, well, thank you for watching the third part of our 3-part video for Chapter 2, Section 3.